Hello everybody, my name is Reese and this is my short video series where I explore how to do cool things in SPSS in less than 10 minutes. In today's video we'll be exploring Factorial ANOVA or two-way analysis of variance in the scenario where we do not have a significant interaction. Just before we start using SPSS today, let's quickly revise what ANOVA is. So an ANOVA stands for Analysis of Variance. It's very similar to a t-test in that it allows us to compare means across our categorical IV on our metric dv or dependent variable. I have already performed videos on one-way ANOVAs, so feel free to check them out. Also feel free to check out my video on interactions as well. In today's analysis, we'll be exploring a factorial ANOVA with two independent variables. Those independent variables are training method and gender, and we'll be looking at how both those variables impact confidence starting a new job. I would like to draw your attention to the fact that this data is made up. I have simulated it for the purposes of this video. Now, before we run our analysis, let's just take a quick moment to orientate ourselves with this SPSS data set. So I have a data set here that I've made up called training.sav, and you'll see here that I have 3 columns. So each one of these columns represents one of my variables. I have training method, my first independent variable. I have gender, and I have a confidence level for all these participants. So if I move to the variable view very quickly, you'll see here that training method has 3 levels. So I have one-on-one training, group-based training, and I have online training. Under gender, we have males and females, and for confidence, we have confidence level entering a new job. It doesn't have any values because, of course, it is a scale variable here. So this is my dependent variable. Now, we will be going to analyze general linear model univariate today, but I would just like to say that if this was your data set, before running your analysis, you would be exploring the assumption of normality, in which case you'd probably be running some exploratory analysis here. For the purposes of this video, I'm going to assume that all of my assumptions have been met. So in saying that, I'm going to go now to general linear model univariate to perform my analysis. Now, to be perfectly honest, a two-way ANOVA is almost as simple as running a one-way ANOVA. The only difference here is that we have a second independent variable. Now, when you do have a significant interaction, the interpretations can get a little bit more tricky, a little bit more complicated, but for today's purposes, we're not going to find an interaction. So what we're going to find is that whilst there may be an effect of one of our IVs on our DV, at no times do these two IVs interact with each other, causing an effect on the dependent variable. So I'll run this analysis now and you'll see those results exactly play out. So I'll drag my 2 independent variables to be fixed factors. Doesn't matter which order you drag them in, that'll only change the order in which they're displayed in the output. And I'll also drag my dependent variable across there. Now, for what options I would need here, if we were performing contrast, so if we had any a priori hypotheses, I might want to run some of them. I'm not going to be running contrast in this video. I will ask for a plot though, because it is a nice way to demonstrate what the results are telling us. So I'm going to perform a plot here. I'm going to place training method on the horizontal axis of my plot and gender on separate lines. Now I've made that arbitrary decision just based on the fact that training method has 3 levels, so I've dragged it onto the horizontal axis, and gender I've placed as separate lines. In reality, those could be flipped if you placed more importance over on one variable more than the other. Totally up to you there. So I'll click continue. If I was interested in post hoc tests, I might click on that and select an option. However, because I don't actually know the results, or I'm going to pretend that I don't know the results, I'm not going to ask for too many options here, and I might come back and run a secondary analysis if I need anything else. I will, under options though, so I'll just drag these options back into view. I will ask for descriptive statistics and estimates of effect size, just to add a little bit more output. Again, if this was your analysis, if you're running analyses on real data, I would be asking for homogeneity tests as well. So we'll go ahead and select continue and then OK to generate our output. Now going through our output window here, the first table is a little bit boring. It's just telling us the sample size and each level of the independent variable. Would be useful for reporting in a method section or at the start of a results section. So you can see here that I had 40 people in each level of the training methods, and 60 of those people were male, 60 of them were female. For my descriptive statistics here, this is a breakdown of all of the marginal means. So if you wanted to break down what's happening at each level of both of the IVs, you could. I prefer, though, to look at the graph initially. I think the graph paints a more of a holistic view of what the data is trying to tell us. So from this graph here, it looks like confidence seems to be higher starting a new job when training or induction's been performed on a one-on-one basis. You can see here quite a big dip here for group-based training, which is very similar to online. So it starts up high for one-on-one, goes down for group-based, and then plateaus a bit for the online training. Comparing the blue and green lines for a moment. So here we have blue lines representing males, green lines representing females. There doesn't look to be a large difference between males and females. So this blue line and this green line are very close to one another. So just by looking at this graph, I can already predict that there's going to be no effect or no difference across gender. And I also am going to predict that there's no interaction. So let's just briefly describe what an interaction is again. So an interaction is when the effect of one IV, so here on the x-axis, on my dependent variable, the thing that's on the y-axis, is somehow different or changes according to levels of my second IV, which are represented by the different colors here. So let's break that down in a little bit more basic terms. So you can see here the effective training method is very high for one-on-one training, goes down for group-based, and then plateaus or just goes a little bit up for online. Can everyone see that that effect there is consistent or the same for both males and females? So the effective training method on confidence does not change or differ according to whether the participants were male or female. So this is why in this data set we have no interaction. The effective training method on confidence levels are the same for males and females. And if we go up to our ANOVA table here, we see exactly that. So here, these three rows in the middle, these represent the F ratios or the effects of each of the IVs and the interaction effects. So for the interaction effect here, training method, little star symbol by gender, you'll see here my F ratio is 1.227 with a p-value of 0.297. So this is greater than 0.05, which indicates that this interaction effect is not significant. In other words, the effective training method on confidence levels does not differ or change according to gender. So you can see very clearly here no interaction. Similarly, for the main effect of gender, that's also not significant. That's because the blue and green lines were very close to each other. However, you can see that the effect of training method is significant with quite a large effect size as well. So training method is in fact having a significant effect here. So if this was real data, this is essentially the thing that you'd be following up on, this effective training method. Based on the fact the interaction is not significant, our focus here would shift to the effective training method alone. Now, in which case you could go back into general linear model and univariate, and if you were perhaps interested in contrast, you could perform contrasts. If you wanted to look at just some basic pairwise comparisons, which I'll do here. So I'll drag training method across, click on compare main effects, and let's Bonferroni adjust them. That'll just control for my type 1 error rates. Click continue, then OK. I'll get some extra output here, which shows me that there is a significant difference between one-on-one training and group-based. So the confidence levels were higher in one-on-one compared to group-based. That effect was significant. Similarly, the effect of one-on-one versus online was also significant. However, there was no difference between group-based and online, which the graph suggests as well. And that's essentially Factorial ANOVA with no interaction. You perform your analysis by dragging both your variables across. You assess the p-values to see if there is an interaction. If there is not, you follow up the significant main effects with either pairwise comparisons or planned contrasts. And it's as simple as that. That wraps up today's video on Factorial ANOVA. Hopefully from this video you can see that a Factorial ANOVA, when the interaction is not significant, is as simple as following up the significant main effects in a similar way as you would in a normal one-way ANOVA. In my next video, we'll be exploring significant interactions in factorial designs. You will see that when the interaction is significant, the analysis becomes a little bit more fun, a little bit more interesting. Alright guys, thank you for checking out my video series, Cool Things in SPSS in less than 10 minutes. I will catch you next time.